Hello everyone, welcome to Maths with Mr. J, and today I'm going to show you how to find sequence given the term of the sequence. Solution. We take question 1. The first and the fourth term of GP are 3 and 24 respectively. Find I the common ratio R and II the sequence. Solution. The formula of finding the n term of a sequence is given as Tn equal to a r raised to the power of n minus 1, where a is the first term, which is given as 3. When n is 4, the fourth term is equals to 24. Now what we do, we substitute this value into the main formula, which is T4 is equal to a is 3, which is given, r is not given, n is 4 minus 1 equal to 24. If we continue, we have 3r raised to the power of 4 minus 1 gives us 3 equal to 24. Next step, we divide both sides by the coefficient of r cubed. That is 3r raised to the power of 3 all over 3 equal to 24 all over 3. 3 we cancel 3, left with r raised to the power of 3 equal to 3 into 24 gives us 8. Next step, we find the cube root of both sides. That is cube root of r raised to the power of 3 equal to cube root of 8. Cube root we cancel cube, left with r equal to cube root of 8 is 2, because 2 is that smallest number that you can multiply by itself 3 times to give you 8. This answer question I, which is the common ratio. Now we have to look for the sequence, which is II. Now we can find the sequence if we know the first term, which is a equal to 3 and r is equal to 2. To generate the sequence, we write the first term, which is 3. Because it's geometric progression, we have to multiply by the common ratio, which is 2. 3 times 2 gives us 6. The next term is 6 times 2, which gives us 12. The next term is 12 times 2, which gives us 24. The next term is 24 times 2, which gives us 48, and so on. To check if our answer is correct, we look for the first term, which is given as 3. 3 is the first term. Then we check the fourth term. The fourth term from the question is equal to 24. If we check the fourth term, this is the first term, second term, third term, and the fourth term is 24. So our answer is correct. Now we proceed to example 2. Example 2. If the third and the sixth term of GP are 8 and 64 respectively, find A, first term, B, common ratio, and C, the sequence. Solution. First, we write the formula of n term of GP, which is given as Tn equal to a r raised to the power of n minus 1. When n is equal to 3, we have T3 is equal to a r raised to the power of 3 minus 1. If we simplify this further, we have T3 is equal to a r raised to the power of 2. And T3 means third term. Third term is given as 8. So we have 8 is equal to a r raised to the power of 2. We call this equation 1. Then when n is equal to 6, which is the system, we have T6 is equal to a r raised to the power of 6 minus 1. If we simplify further, we have T6 is equal to a r raised to the power of 5. And T6 is given as 64. 64 equal to a r raised to the power of 5. We call this equation 2. Next step, we say equation 2 divided by equation 1. That is a r raised to the power of 5 equal to 64 all over a r raised to the power of 2 equal to 8. Now, a we cancel a. R raised to the power of 5 divided by r raised to the power of 2. The 2r, we cancel 2r, left with r raised to the power of 3 equal to 8 divided by 64 still give us 8. Then we move further. We take the cube root of both sides. That is cube root of r raised to the power of 3 equal to cube root of 8. Cube root we cancel cube, left with r equal to cube root of 8 is 2 because 2 is the smallest number that can multiply itself 3 times to give us 8. Then put r equal to 2 in equation 1 above. In equation 1, we have a r raised to the power of 2 equal to 8. Equation 1. Then when we put 2 in place of r, we have a into 2 raised to the power of 2 equals to 8. A squared will give us 4, which is 4a equals to 8. Then to get a, we divide both sides by the coefficient of a, which is 4. That is 4a over 4 equals to 8 all over 4. 4 cancel 4, left with a. A divided by 4 gives us 2. Therefore, a is equal to 2 and r is equals to 2. This answer question A and B. Now, question C, we have to generate the sequence. How do we generate the sequence? A is given as 2 and r is given as 2. The sequence will be first term, which is 2. Because it's geometric progression, we multiply each term by the common ratio, which is 2. 2 times 2 gives us 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, we have 64, and so on. To check if our answer is correct, T3 is equal to 8 and T6 is equal to 64. We go back to the sequence. The T3, which is the third term, is 8. If we count from here, 1, 2, 3. And the system is 64. So our answer is correct. Then we move to example 3, which is the last example. Example 3, if the third and the fifth term of geometric progression are 12 and 48, find the sequence. Solution. The formula of n term of geometric progression is Tn equal to ar raised to the power of n minus 1. When n is equal to 3, T3 implies ar raised to the power of 3 minus 1, which will give us 12 from the question. Then if we move further, we have ar raised to the power of 2, because 3 minus 1 gives us 2, equal to 12. We call this equation 1. Then we move further. When n equal to 5, we have T5 implies ar raised to the power of 5 minus 1 equal to 48, which is given. If we simplify further, we have ar raised to the power of 4 equal to 48. We call this equation 2. Now we say equation 2 divided by equation 1. That is ar raised to the power of 4 equal to 48 all over ar raised to the power of 2 equal to 12. We cancel r squared to r raised to the power of 4 will give us r squared equal to 12 into 48 will give us 4. Next step, we take the square root of both sides. If we take the square root of both sides, we have square root of r squared is equals to plus or minus square root of 4. Even roots gives us plus or minus. Square root will cancel square, left with r equals to square root of 4 is plus or minus 2 as the answer. Now we want to look for the first term. Now we want to look for the value of a. We say first case, when r is equals to plus 2, put in equation 1 above. Equation 1 is ar raised to the power of 2 equal to 12. If we put the value of plus 2 in place of r, we are having a into 2 raised to the power of 2 equals to 12. 2 raised to the power of 2 will give us 4, which is 4a equal to 12. Then to get a, we divide both sides by the coefficient of a, which is 4. Then we have 4a over 4 equals to 12 all over 4. 4 we cancel out 4, left with a equal to 4 into 12 gives us 3. Now to form a sequence in this first case, where a is equal to 3 and r is equals to plus 2. Now the sequence will be first term is given as 3, r is the common ratio. In GP we multiply by the common ratio, which is 3 times 2 gives us 6. The next term is 6 times 2 gives us 12. The next term is 12 times 2 gives us 24. 24 times 2 gives us 48. 48 times 2 gives us 96, and so on. To check if our answer is correct, from the original equation, third term is given as 12 and the fifth term is given as 48. Our answer is correct. Now we consider the second case. When r is equal to minus 2, put in equation 1 above, that is a r raised to the power of 2 equals to 12, which is equation 1. When we put minus 2 in place of r, we have a into minus 2 all squared equals to 12. Minus 2 squared is equals to 4, which is 4a equal to 12. Next step, we divide both sides by the coefficient of a, which is 4. That is 4a divided by 4 equal to 12 divided by 4. 4 cancel 4, left with a equal to 4 into 12 gives us 3. Now, to form the sequence, when a is equal to 3 and r is equal to minus 2. Now, the first term is given as 3. To generate the sequence, we multiply by the common ratio, which is minus 2. 3 times minus 2 gives us minus 6. Minus 6 times minus 2 gives us plus 12. Plus 12 times minus 2 gives us minus 24. Minus 24 times minus 2 gives us 48. Minus 2 times 48 gives us minus 96, and so on. The term in this sequence has both positive and negative number. To double check if our answer is correct, the third term is plus 12, which is the same as the first sequence, and the fifth term is plus 48. So our answer is correct. If this helped, please subscribe, like, and share. Thank you very much. See you in my next video.